Welcome to Chapter 1, where we'll dive into the fascinating world of rigid body physics in Blender. In this chapter, we'll explore how to simulate real-world physics by applying rigid body dynamics to your objects. Let's get started. So our last step before we actually start adding a rigid body physics simulation to our cube is understanding how Blender calculates physics just a little bit more. For example, I have this power brick from my MacBook. If I drop this from a small height, you can see that it kind of rolls out of the scene here, but every single time I drop it, it drops just a little bit differently because I can't hold it at the perfect position, right? But as soon as it hits that surface, instantly in real life, right, there's some kind of physics going on here. Blender has to calculate those physics, right? Real life physics just happen, but in Blender, as soon as something's dropped or it touches another surface, it has to be calculated how it's going to actually interact with that surface, right? There's friction, there's weight, there's gravity, just like in the real world. So as soon as I drop this, it has a certain weight, it'll bounce off of this, which has a certain friction or bounciness, okay? And there's a certain material on this object as well. All of those different factors have to be calculated within Blender before Blender can show you the actual physics simulation, right? And that's where that baking comes into play. So as soon as I drop this, we don't really know what's going to happen in real life. Blender certainly doesn't know, and it has to calculate that either in real time, or we have to bake our simulation to tell Blender, hey, please let me know what's going to happen as soon as I drop this object.